I want to begin by talking about the prerequisites to doing design calculations for clean agent systems in the Viking Revit toolbar. So before we get to the design phase of this with Brendan, I wanted to talk to you about NFPA 2001 and what are clean agents. So first we need to determine what the clean agents are that we're going to utilize. And in NFPA 2001, they are going to give us the direction on clean agent systems. So that is a handy manual to have around. Then we have the FSSA guide, and so this is the pipe design guide, the FSSA special hazard design guide. So these guys are also very helpful in designing clean agent systems. You also want to consult the manufacturer's design manual. In this case today, we'll be consulting our BSH 1230 and BSH 200 design manual. And so these are going to be key into developing a clean agent system. The chemical agents that are available in the Clean Agent Assistant in Revit are going to be the FK5112, which is the 3M Novec 1230, and HFC 227, which will be Chemours FM200 fire suppressant. We also have the design manager. So if you are designing in AutoCAD, you can use the VSH design manager to calculate. And we have the same agents, the halocarbon agents, FK5112, HFC 227, available in the design manager if you're designing in AutoCAD. And then we're looking forward to having argon, which is chemical IG01, in the future. And we're also looking forward to having IG100 nitrogen in the near future here, maybe in March of 2021. The typical applications for clean agent systems are going to be Class C type hazards, data centers, cell sites, telecommunications, hospitals, and power generation. These are all going to be Class C type hazards if they're energized. And then we have more applications. On the next slide, we have valuable assets, rare book artifacts, museums and art galleries, research labs, law enforcement, evidence storage rooms. These are all typically Class A type hazards. These are non-energized. So we were looking at these applications as Class A. Then we would have industrial process. The industrial process pharmaceuticals, that would be like Class B type fire hazards. Typically, the AHJ is going to be concerned about reducing and eliminating water discharge. And your initial fire protection, just determining what that's going to be. The AHJ is going to want to know what we're going to be doing, and then catching the fire in very early warning stages. So that's the AHJ's primary concerns. The end user is going to be concerned with business continuity, communication, and irreplaceable assets. A lot of people want to know how difficult the clean agent systems are. And if you know how a deluge system operates, then you use it for total flooding. You do the same thing with clean agent. So if you have a deluge system, dry valve, dry pipe system, and you have an inlet and an outlet on the valve and a priming chamber, the clean agent system is relatively the same thing. You have a tank storing the agent, and the valve has an inlet and an outlet to downstream pipe, and it has a nozzle for distribution of the agent. And so you have the valve has an inlet and an outlet and a priming chamber, very similar to a deluge total flooding system. The clean agent systems are also going to be total flooding. So you'll be looking for halocarbons, HFC 227, FM200, 3M Novec 1230, FK5 112. These are total flooding agents. So the systems aren't very difficult at all to understand. Then we have how do we get to the downstream pipe network? Well, we're going to use hardware, flexible hoses, or swivel adapters going directly from the tank to the pipe network. So these are going to be your first components, the first hardware components that you're going to be utilizing to go from the tank to the pipe network. Once we install the pipe network, we are going to be required to have ASTM53 seamless or electric weld grade A or B pipe along with class 300 fittings. Then we will have the nozzles. And then the nozzles are two different styles. We have the nozzles with the hex head and orifice plates that are going to be installed inside the nozzles. And the orifice plates are going to be drilled to a specific orifice to be able to deliver the agent in 10 seconds. And that's for the 3M Novec 1230. With the FM200, we're going to have nozzles that we actually have to drill the orifices per the calculations. So the calculation is going to tell us what orifice size for delivery of agent in 10 seconds. So the nozzles are a very important part of the design process. The next step is to determine what class of fire. And in the applications I showed you earlier, we have class A fires, which are combustible, ordinary combustibles materials such as wood, cloth, paper, rubber. So libraries, artifact rooms, anything that's non-energized is typically going to be classified as a class A fire. Class B fire is a little bit different. We're going to be looking at flammable liquids, combustible liquids, petroleum greases, tars, oils, oil paints. These are going to be typical Class B fires. And then we have the Class C fires that I was talking to you about earlier in the applications, the electrical energized. And this is going to be data centers, telecom rooms, things of that nature. Then we also need to know the definitions of clean agent. It's a fire extinguishant. It's electrically non-conductive, and it doesn't leave a residue. So that's what the definition is of a clean agent. And we also need to know the definition of an engineered system. And so this is a system requiring individual calculation and design to determine the flow rates of the nozzles, the pressure, the pipe sizes, the area and volume protected by each nozzle, and the quantity of agent. So we're going to be using the calculation software in it's going to be the VSH Design Manager in the Revit toolbar to calculate. So we're going to need to know what classifier is so we can determine what the design concentration is going to be for the agents that we select. In NFPA 2001, we can determine the total flooding quantity. So we do a quantity calculation. We have to know, this formula here is in NFPA 2001, and we have to know the quantity of clean agent, which is W, and we have to know the net volume of the hazard, which is V, Victor, calculated as gross volume. We have to know the design concentration, and I'm going to show you how to understand the design concentration in the next slides. So that's C, and then we need to know the basic atmosphere height above sea level or height below sea level in order to do this calculation. It's nice that the calculation can be done. You don't have to do it by hand. It's going to be in the software. So you enter the length, width, and height of the hazard and the design concentration. So for design concentration, if you look at the tables in NFPA 2001, this is table for FK5112 or 3M Novec 1230. So if I want to design to 70 degrees Fahrenheit, and I want a 4.5% Class A or Class C energized design concentration for the 3M Novec 1230, then I'm going to see that this is going to be 0.0475 by volume. We go to the next slide, it'll show you how it's selected. So we select the agent, transfer to the next slide, and we have the temperature. We go to the next slide, and we have the design concentration here, somewhere between 4 and 5%, and I'm looking for 4.5% because that's what NFPA 2001 tells me I'm supposed to use. So we're going to use a flooding factor of 0.04075. That's going to be the flooding factor that we're going to use in our calculation. If we transfer to the next slide, I have HFC 227 total flooding quantity. So I'm looking for the flooding factor here for FM 200. So we have HFC 227, and we'll go to the next slide, would be 70 degrees. And then we go to the next slide, and it's going to give us a 7% design concentration here. That's going to be for Class A hazard. And then we have, so we have 0.0341 flooding factor for HFC 227. Transfer to the next slide. It's going to show us the toxicity information that we need to know for halocarbon clean agents. If we look at FK5112, what we're going to be working with today, we have a NOAL of 10. Now this is a no adverse effect level, 10%. So our design concentration can't be 10% or higher, because if we go higher than that, if it's greater than 10%, we're in the low AL. This is a low adverse effect level. So this is going to have an impact on us if we're in the hazard. There's going to be a low adverse effect level. Another agent that you can use with the Design Manager software is the HFC 227, and it has a NOAL of 9. We're typically going to be designing at 7% design concentration for Class A fires here, and 7.3% for Class C. So we're below the NOAL, and then we have the low AL is going to be at 10.5. So this is where we're going to have a low adverse effect level. There's going to be some type of impact. We're going to need to get out of that hazard during a discharge so we don't have a low adverse effect level. Transfer to the next slide. We're looking at the extinguishment. Now, there's two things going on here. We have a Class A minimum extinguishing concentration. So this is out of the table in NFPA 2001. So extinguishing concentration and design concentration are two different things. So we look at the minimum extinguishing concentration. This is done through testing. And then we have safety factors. And if you look down below, it says Class A extinguishing concentrations are determined in accordance with 5422 times a safety factor of 1.2. So if we look at the design concentration for Class A, it's different than the minimum extinguishing concentration. So you look at the FK5112, it's 3.3 MEC, minimum extinguishing, and 4.5 Class A design concentration. So what we've done here is we've added a safety factor for 4.5%. You see that a lot of times with specifications, and they say you'll have a safety factor of 1.2 times, and what they're talking about is 1.2 times the minimum extinguishing concentration. At HFC 227EA, we have an MEC of 5.2. And then that gives us a design concentration, a Class A of 6.7, and a Class C design concentration of 7.0. Now, this is out of the tables in NFPA 2001. So if we go to the next slide, we'll show you what is in the manuals for the VSH 1230 3M Novec 1230 system. So for nozzles up to 14 feet above the finished floor, we have out of the manual, and it shows us Class A fire is 4.2, and then there's a number there, number 1. It says NFPA 2001-2008 edition. So you need to know what edition you're designing to when you are going to design a system. So designers, engineers, you need to know what edition you're using. Because now in the second line, I have Class A fire 4.5%. So this is Class A fire 4.2, 4.5. What does that mean? Well, 4.5% by volume, and then there's a little number 2 there. It says NFPA 2001 editions 2012 and later. So 2012, 2015, 2018, we're going to be using 4.5% by volume for a Class A fire. Class B fires, you typically consult your manufacturer because there's so many different types of fuels, but you have 5.9% is pretty standard. But really consult your manufacturer for Class B type fires. Class C type fires are what I talked about earlier: energized, telecom, data centers. So we remember that these are energized, and we have 4.5% volume by volume in NFPA 2012 and later. This is for nozzles up to 14 feet. Now, if we transfer to the next slide, we'll look at nozzles between 14 feet and 17.9. So now we have another design criteria for nozzles that are over 14 feet up to 17.9 feet. And so we have Class A fires in the NFPA 2001-2008 edition are now 4.5%. So we have to increase the design concentration a little bit more to comply with the height, with the extended height. Same thing with Class A fires for 2012 edition and later, we have 4.8%. So 4.8% for Class A and 4.8% for Class C. Just a little bit more agent is needed to meet the design criteria of the extended nozzle height. And you can also see that the Class B fire design concentration has increased to 6.3. It was 5.9 at 14 feet. At 14 feet and higher extended height, we're looking at 6.3%, or consult your manufacturer for Class B type fuels. So going to the next slide, we are looking at the VSH 200, which is with the Chemours FM200 fire suppressant. We have HSC 227. The MEC is 5.2. That's the minimum extinguishing concentration. And then we have a design concentration in NFPA 2001 Class A is 6.7, and Class C is 7.0. Well, when we went to do our testing for UL and FM, we tested at 6.9%. So this is a good to show you that we have, as a manufacturer, we tested at 6.9%. Even though NFPA 2001 says you can use 6.7, with the VSH 200, you have to be 6.9% by volume for Class A. For Class C fires, 7.3% by volume, and this is out of the manufacturer's manual. So that's 7.3 versus 7.0 in NFPA 2001. So you have to be careful to look at the manufacturer's manual to make sure that the design is proper. It's correct. So going to the next slide, we have the, we're going to wrap this up so I can turn this over to Brendan to show you the Revit design. And so the things we need to know, we need to identify the volumes we're going to protect. Remember, we have a Class A, B, or C type hazard. We have to know what we're going to protect. Then we have to determine what type of agent we're going to use, the design concentration, the temperature of the hazard, and the height above sea level. That's all going to be included in the formula that we're going to use to determine the quantity of agent. The calculated required agent is going to be done in the software. So you'll look forward to seeing how that's done by entering the length, width, height, the height above sea level, the temperature, and then we get the required quantity. We're going to identify and place the supply of the containers. So we need to know where the containers so that we can do a pipe calc. So we're going to want to be able to do that by knowing where the tank's going to be, and then we need to determine the nozzle location, because we're going to do a pressure drop calculation for the hazard. Then we need to connect the nozzles to the pipe supply and then run the calculations. And so I'd like to turn this over to Brendan at this time to show us how this is done in Revit using the Viking tools for Revit.
Cool. So now that we've moved this into Revit, I'm working in Revit 2020. We're going to be utilizing the Clean Agent Assistant portion of the Viking tools for Revit. So this is a free add-on for Revit. It supports Revit 2017 through Revit 2021. I'll show you where you can get that at the end here. But what this is going to do is add a extra little ribbon to your Revit in here with all the tools and utilities that we provide. So today I'm just starting on a blank mechanical template, and we're just going to walk through the real basics of designing and actually calculating one of the Clean Agent systems. So now that we have all that background, we kind of know all the various steps that we're going to need to go through. So generally when you start, you may have something like a existing Revit model. So in that case, you could go to the Insert tab. You could link to that existing Revit model. You may have had a CAD model provided to you. You may even just be working on some type of PDF. So usually you can import those, use them either as the reference geometry or simply trace over them to create some sort of reference geometry. But just for the sake of simplicity, we're going to draw a couple walls here and start from nothing. So we're going to start with a hypothetical scenario here where we're protecting maybe a 30-foot by 30-foot server room that's about 9 feet high, and we're going to protect it with Novec 1230. And another key piece of information is that it is in Denver, Colorado. So to start, I'm going to draw some of the walls here. Pretty simple, basic Revit functionality. As we said, it's about 9 feet high. In a normal scenario, you're probably going to insert a ceiling and whatnot here, but we'll just draw the walls and keep it simple. One thing I always like to point out that you pay attention to is the location line, and I'll show you why this can be a little bit hazardous. So if I were to just start drawing these walls here, go 30 feet by 30 feet, and then connect them up, it all looks pretty good. We see a distance of 30 feet, but by drawing along the wall center line here, I'm actually taking out half the width of the wall, which is 8 inches here, so 4 inches from every side of the interior volume. So we always like to point out that it's quite important to pay attention to where you're drawing and what dimensions you're basing things off of, because in this scenario, we've now lost essentially 8 inches of volume in a vertical, or 8 inches of area in a vertical and horizontal sense. One of the other interesting things that you can do within Revit is actually define the location. So this may have already been defined if you've been furnished with a model, but if it wasn't, you can just come in here. We said our data center is in Denver, Colorado. We can search for it. And once we've set that location, that will actually allow us to extract the volume and the elevation automatically out of Revit. So it saves you a little bit of looking up, exactly where you are in the world and what elevation above sea level you're working with. Something else you can do is also define some of the project information if this wasn't predefined, and this will get automatically imported into the Clean Agent Assistant project, and it will be reflected on all of the outputs. So now that we've defined our basic square geometry here, we need to label this interior as either a room or a space. So usually in the MEP trade, we'll be dealing with spaces and we'll leave the rooms to the architects. But again, for simplicity, we'll just draw a room. We'll make the room tag visible here. This is another area to pay attention. If I was dealing with a ceiling or some type of roof or floor above this space, I'd be able to utilize that to come out with an accurate height of this volume here. But since it's going to have nothing above it, in this simplistic case, I'll just also specify the 9-foot height here. And I'll just call this our server room. So we've had some interesting scenarios with things like sloped ceilings or roofs where this is actually quite handy, using the roof or ceiling as a reference point for actually getting a pretty nice accurate height or kind of average height out of a non-standard room. So I've just labeled my server room here, and I've kind of completed a lot of the basic tasks I need to start jumping into the Clean Agent Assistant. So I'll go to the Viking tab on the ribbon, start the Clean Agent Assistant. You'll see the following pop up, and I'm just going to click Start a New Project. So the way we've designed this is in this kind of workflow, there's a little bit of a wizard, and we walk you through step by step each of the things you need to do and know in order to actually implement one of these Clean Agent systems. So the first thing this is going to do is tell me to click Next, and I can choose any room or space object in the model that I want to protect. So when I hit Start here, I can just go pick my room in the model, and if I happen to have multiple rooms, I could pick multiple if I intended to protect them all with the same system. But since I only have one here, I'll just click Finish. Once that's done, you'll be presented with a summary of the extracted volume. So you'll see here, server room 1, main, we have our length and width, our surface area, as well as the extracted height. So always verify that this is in an accurate value, and you can adjust it right here if it's not. Another thing we do is automatically provide an area for a floor or a ceiling void. So often in a data center, there may be a subfloor that you'd like to protect with the same containers as the main room. So just by carrying over the surface area, you're able to input a height here and include that pretty easily. You'll also notice a reduction column. So this is if you have a permanent structural reduction. As Doug covered in his presentation, this really has to be a permanent structural reduction. It's not just, oh, I've got some boxes in the room. So use this with care, and that's why there's no attempt at automatically trying to input anything here. You should really be specifically knowing what you're doing when you're defining a reduction. And lastly, you can define an extra quantity of agent you'd like to discharge to that room. So usually you can just accomplish this via design concentration, but in some more complex scenarios, you might have to add some extra volume here or some extra agent here for balancing purposes. So if I happen to have other rooms, I can go out and pick them again or manually add some, but we're going to stick with our one main volume here. Once I hit Next, we're at the Configure System stage. So this is where we need to know a little bit about what we're doing. So as we said, we're dealing with the 3M Novec 1230 here, but we also have FM200 as an option. We can choose the approval, so either UL or FM approved. We input our discharge time, so this is generally going to be in the 6 to 10 second range. This is defined by NFPA. Sometimes we'll see designers opt for a discharge time of about 9 or 9.5 seconds, and the reason you might do this is it will give you a little bit of leeway on the calculations in the event that there's some minor piping changes later, which of course never happens. Next, we have our altitude. So again, we were in Denver, Colorado, which was about 5,500 feet above sea level. So that's automatically included for us. We can define our room temperature, and then the big parameter here is the design concentration we're going to use. So by default in Novec 1230, this is going to be 4.5%. If this was a FM200 job, by default, that's going to be 6.9%. So in Novec 1230, you're kind of covered Class A and Class C, and this being a data center, we're protecting it as Class C. I have the same design concentration, but if I was an FM200, I would have to make absolutely certain that I went and adjusted the design concentration up to the required minimum. The final option you have here is to choose between the two different pressures. So this is defining the pressure of the containers. So these are the pressures that Viking offers, a 360 PSI and a 725 PSI system. Generally, for kind of short pipe runs and simple scenarios, the 360 PSI systems are more than sufficient. But if you have, pipe runs of, in the 100 plus feet range, you may need to go to a 725 PSI system. When you hit next here and you've kind of validated all of your inputs, you're going to be at the place container screen. So what we've done is we've kind of finalized the agent quantity required, which is reflected here, our minimum quantity of agent, 258.82 pounds. Then we've gone out and actually chosen a container we think will probably work for you. This is a best guess. It's not always guaranteed that the hydraulic calculation will work out. But for here, we believe that one of the 390-pound containers would be sufficient. So you're then presented with two pictures. You get to essentially choose what type of supply you would like to place. On the left-hand side, we have our 2x1 cabinet. This is a fairly new offering, but it is a combined pre-action and clean agent system. With the smaller clean agent containers, the container actually fits right into the cabinet. But if you are dealing with the largest containers, it's simply secured to the outside of the cabinet. So this is a 2 or 3 inch pre-action valve, a clean agent system, a release and control panel, all in one, very convenient. And one of the reasons you might opt for this is that generally, even if you are installing a clean agent system, you're going to see a pre-action system installed alongside of it. The other option here is to utilize a single container with a swivel adapter. So again, you're just going to be hard piping out of the end here. We're going to go with this option, keep it nice and simple. When I click the icon here, it's going to queue that 390-pound container up for placement. So since I'm just going with the standalone clean agent system, I can place it right in the hazard that I'm protecting, and I'll put it right in this corner up here. Once I click, I just escape out of the Revit family placement. It's going to come in and actually draw an initial section of pipe and a coupling for me. So if I look at this in a 3D view, we'll see that it's giving you an accurate height and a pretty good idea of what type of floor area this is going to take up. So from a coordination perspective, this can be quite helpful. Something you will usually see is that this container and that pipe will actually be angled back towards the wall, and you're mostly going to do this so that you have something to secure that piping to. So you can kind of rotate it over, nudge it back over towards the wall. Don't need to be, super exact there, but you can imagine you're running over the wall, securing, running up to the ceiling, and then running out to any nozzles. So now that we have our supply defined, we can go to the next step of the wizard, and this is going to give us a estimate of how many nozzles we're going to need to protect each volume segment. So this is again a best guess based off of the length and width, the coverage area. And then we're going to actually give you our best guess at a size as well. And this is mostly driven by how much agent you're trying to push into that volume based on the quantity of nozzles. So there's an upper limit of how many pounds of agent can be pushed through each nozzle, and that's used there for helping size them. At the bottom, you'll see some basic diagrams indicating the coverage area. So our nozzles come in 180-degree variants and 360-degree variants. They actually cover the same square foot footprint, be it the 180 or the 360, where the 180 obviously has a longer throw. So in many scenarios, you can actually get shorter pipe runs and an equivalent area of coverage out of the 180-degree nozzles. So that's always interesting to keep in mind. So I'll just use a 360-degree nozzle, just so people are, maybe a little more familiar with that. It's a bit more sprinkler-like in terms of just normal pendant or upright sprinkler. So I can choose the 2-inch, matching the suggested nozzle size, click Insert Nozzle here, and it's going to queue that up for placement. So we had said that our ceiling is at about 9 feet, so we need to be within about 1 foot of the ceiling. So I'll specify my height of the nozzle at 8 feet, and then I'm just going to roughly center this in the room. You can see it's about 15 feet from the top wall center line and 15 feet from the bottom. If you want to be really exact here, you can go in and make an aligned dimension and equal those variances out. Once I've placed that nozzle, I'm then presented with the following screen. So it's a big wall of text that's basically saying, okay, you have your nozzles and you have your supply. You now need to connect them up. So one thing I'll note is that when we drew that initial pipe segment for you out of the container, we created a Revit pipe type called the Viking Clean Agent pipe type. You don't actually have to use this pipe type, but it's kind of a nice generic approach at class 300 fittings. So if you're trying to do this and you don't have your own pipe types, it's definitely a reasonable approximation, and it should give you some good pipe takeouts in terms of real pipe cut lengths and whatnot. So one of the easiest things to do is just draw right off the end of that little piece of pipe we created there. So with a 9-foot ceiling and a nozzle at about 8 feet, we probably want to run up to maybe 8 foot 10 inches. And then we'll just run down to the intersection here with the nozzle. And then when we're looking at the nozzle down here, we can also just draw from the nozzle straight up to that 8 foot 10 and bring it out to meet up with our pipe over here. Looks like I overran a little, so you just delete the little extra section, turn that back into an elbow, and you're good to go. So if we look at this from a 3D perspective, it's pretty simple. We've got our supply running over to the wall, secured against the wall, up over and out to our 360-degree nozzle in the center of the room. So now that we have our fully connected system, we can click next on this wizard screen here. And this is going to put me in a mode where I can go into Revit and choose any of the pipes that are present on that pipe network. And that's going to extract all those details out and get it ready for hydraulic calculation. So when it sees a nozzle, it's going to ask you to verify where you intend for this to discharge. So since we are protecting just a singular volume here, we don't really have to do anything, but if we had a subfloor and a main, we would have to make sure we accurately assign that here so that the calculations know where it's delivering nozzle, where it's delivering the agent in terms of quantity to each nozzle. So when I click OK, I'm ready to run my hydraulic calculations, and I'll just hit calculate. It's going to go off, run the calculations. So obviously a pretty simple system. There was no errors in the calculations. In the event there were errors, you would be presented with a little screen here informing you what they are. So something you might encounter is that the pressure at the final nozzle is too low. So you're going to want to rectify this by choosing a larger supply. So maybe we size up the container. Maybe we need more than one container. There's a handful of different errors you might encounter. And usually the design manual is a pretty good reference in terms of helping you resolve some of those. But if you're ever encountering a really complex scenario, you can always reach out to Doug or the digital team, and we can try to help you through it. So since there were no errors, I have two options here. I can create a submittal or create a schedule, and I can always do these later. So I'll begin by creating a submittal. This is just going to open up your default web browser with a summary of your project, all the system details that you selected. So it's got your design concentration, the specified discharge time. It has the information related to the listing and approval of the hydraulic calculations used. So these are UL and FM approved. They are listed with the system, so you couldn't kind of drag and drop these calculations to another manufacturer. You have your calculation messages, so if there's any warnings or errors, that would also be presented to you here. We have our quantity calculation summary detailing our steps and inputs that arrive at our minimum agent quantity, our desired container, our center-to-center pipe run, as well as the resulting pressure drops at each node. And we have our nozzles. So here again, we have the actual discharge quantity from that nozzle, the discharge time, and we also are provided with that orifice drill diameter that is going to be used in the ordering stage. So this is, again, a key output other than the fact that the entire calculation is valid. Right here, you're going to need to know this. We also provide some results of pressure relief venting calculations per FSSA, and I'll show you how you can customize this a little bit. And then finally, we have a bill of materials for the system. So this does not include the releasing or detection or control panels. but it does include the releasing device for the system itself. And then we have just some final information here. So a simplified spool with cut lengths and fittings associated with those segments. And then some parameters that might be interesting from an estimating perspective in terms of length of pipe and total fitting quantities. So if we go back into Revit here, we'll see that the Clean Agent Assistant has gone back to kind of the larger form here. So this is where you can get a little more granular, customize some additional things. So if, for instance, you didn't pick a pipe type, but if you wanted to use a Schedule 40 pipe, you can select that here. Modify room volumes, modify your container you're using as your supply, that kind of thing. And then I'll just show the pressure relief venting here. So if you know the materials of construction and their properties, you can modify the max under and over pressure, the humidity and safety factor, and then have that presented on all of your outputs. Another interesting function here is the ability to actually create Revit schedules here. So when I click that calendar looking icon right here, it's going to prompt me for a name for the schedules. So we'll just say server room, and then I can choose what schedules I would like to create. I'll hit next, and these will just pop into Revit right here. And this is all the same information that I just selected and had on the output. So very handy way of actually associating the data with your drawings. Another thing that might be interesting, if I lock my 3D view here, I can leverage the automatic tagging functionality. So this will go in and it's going to actually tag all of my node numbers, all of my diameters. So this is extremely helpful when reviewing the calculations. As you can see, sometimes this gets a little cluttered. So if you use that to initialize the tags, you can just remove them and then take a slightly more measured way of actually inserting them one by one at each of the nodes that you consider to be significant. So again, I'll just quickly tag a couple items here. So from a review perspective, you're really concerned about, what are the node numbers and how can I interpret that hydraulic calculation. So now that we have that there, we can just crop the view down and then actually bring it into a sheet, which is kind of a nice all-in-one package with all of our results and information that we would need for actually using this system. So we've cropped our view here, hide that, just create a basic sheet, nothing fancy. Then we're able to drag in our bill of materials. We can drag in our system information. We can bring the entire hydraulic results, which can be pretty large in the big systems, so might need to be segmented over a couple different sheets there. And then we can bring in our basic node number drawing here. So from our perspective, this is most of what you would need to actually implement one of these systems. So one last thing I'd like to mention is that Doug made a lot of references to the design manual. Whenever you're working in the Clean Agent Assistant, you can just come in, click the VSH 1230 design manual link, and this is going to pop you right out to the design manual, and you can access all the information that we were talking about in terms of design concentrations or nozzle coverages and pretty much any of the guidance you would need for implementing these. So that's just publicly available. So if you're actually interested in obtaining these tools, if you go to the main Viking website, vikinggroupinc.com, there's a digital tab here. And if you go to the Viking Tools for Revit link, you can just sign up and download. Just needs a email and a name basically, and you'll get access. And just lastly, I want to show that under the Resources tab, there's a Frequently Asked Questions. These might help you when you're working through our various utilities, as well as a more full-blown tutorials section, which are YouTube videos, some of which are quite similar or even more in-depth than some of what I showed here today. So finally, if you have any questions, there's a contact us link, and this will go right to the digital team, and we can get you in touch with anyone you need to, be it us or any of the subject matter experts here at Viking. So with that said, I'll turn it back to Taylor. I believe we have a QA code for getting some development hour participation credit here. So
the first question I have for you guys is, does Viking offer all of the products you would need to self-perform on clean agent systems?
Oh, Taylor, yes, of course. We do have offerings to be able to do this, like you just saw Brenda do, the mechanical side of the house for a clean agent system. And we have all the product offerings. We have the Viking VSH 200, the tanks, the hardware and components, the nozzles, actuators, control panels, everything that you need.
Great, thanks. The next question I have is, do the pipe and fittings used for clean agent distribution systems need to be listed?
So, yeah, Taylor, there is a requirement for the pipe to be ASTM 53 seamless or electric weld A or B. That's going to be SCED 40, and it's got to have the fittings all have to be class 300 fittings, and this is all for threaded type pipe. So it has to be the manufacturer. We have anvil pipe and fittings, so you can use those, and they're listed for the pressures that we're going to be utilizing in these types of systems.
Okay, thanks. Is it possible to use one tank to protect 3 separate rooms and have them zoned independently?
No, it's not. You'd have to have one tank for each room if you wanted independent discharge, and that's, I mean, what Brendan showed you today. You'd be able to do that on the same plan set and show 3 separate tanks, 3 separate pipe networks. If they needed to discharge at the same time, that would be possible. You could use one tank to discharge 3 rooms, depending on the volume of the room. You might take 1 or 2 tanks, or maybe more, depending on the size of the volumes.
Okay. Let's see here. How do you add in selector valves and have multiple calc areas?
So there is a selector valve system for the VSH 1230. We call it the multi-zone system. And this is, we can calculate this the same way Brendan was showing you with the VSH Design Manager software. And so we normally would take the largest area, maybe the largest area needed like 11 cylinders as a data center. And if you had the data center was required to have the agent discharge there, we'd have all 11 cylinders. But if you maybe needed 4 cylinders for a battery room, we could select through programming of the control panel and the electric actuator. We could select just 4 of those cylinders and have them discharge through the selector valve manifold into a different hazard. So you have 2 different manifolds. You have a cylinder manifold and then a selector valve manifold. And so the cylinder manifold is connected to the selector valve manifold, and the selector valves would then be downstream pipe to the separate hazards.
Okay, thank you. Let's see, the next question I have here might be more for Brendan. How much does the program cost?
The Clean Agent Assistant within Revit is just freely available. I kind of covered that at the end there. You just get it from digital.vikingcorp.com, but you do require Revit to utilize that.
All right. Can I export the calculation memory to a PDF file to send to my client?
Yes, yeah. The printout that Brendan did at the end there was all the project information, all the data, the hydraulic calculations, and this can be turned into a PDF file as well as the plans that Brendan was doing today. They can all be converted to PDF files and sent to your client, to the AHJ, for them to review.
Okay, and just as a follow-up, I'm not sure if it showed, does the calculation memory include an isometric diagram? If
Yes,
you
it
know.
does.
Okay.
Yeah. When you complete the calculation, you if you're working in the VSH Design Manager software, you can create an isometric view.
Okay, thank you. There's a couple questions here about the QR code, and I just want to answer that. I know people can see the QR code right here to scan for their certificate. You can use like the camera on your phone to scan that, and if it's not working, you can just go ahead and email us either one of these emails. Doug, you can email Doug and he can forward it to me, and we'll figure out how to get you a certificate. I know there's a couple people that are having issues with that. The next question I have for you guys is where would you use the 725 PSI systems, and are there any downsides?
So yeah, sure. The 725 PSI system, Brendan had alluded to, if you're going to put the cylinder in within close proximity of the hazard, 360 PSI is probably a good option, because you're going to be pushing that agent through the downstream pipe. So if you're closer, 360 PSI is good. If you're going to be over 50 feet away, 100 feet, as far as 200 feet away, you're going to need to use a performance pressure, and we call the 725 PSI the performance pressure, because you're still utilizing the same pipe and the same fittings for 725 PSI. It's not high pressure. We've been after marketing for years to just let them know it's not high pressure, it's performance pressure. So the engineers like to know that it's 725 PSI is performance.
Can the Viking Clean Agent Revit program accommodate AutoSprink RVT and or the HydroCAD for Revit platforms?
Yeah, I can answer that. I mean, they're really working on two different things. If you want to calculate the clean agent system, you must use the calculation software that's included in the Clean Agent Assistant. But if you'd like to use their fitting families or something like that, certainly we've tried to make that side of it as independent as possible.